Imagine a small team building a restaurant reservation app called TableSnag. They put their heads down, code straight through the weekend, and launch. Almost immediately, the app is a hit, and local dining rooms start filling up with customers. Getting that first version out the door feels incredible. The code is fresh, the architecture is clean, and the engineers feel they've finally reached the end of the project. In reality, a successful launch is only the first day of a journey that usually lasts for years. The true life cycle of the software has only just begun. Fast forward 3 years. TableSnag has thousands of users, but on Valentine's Day, their busiest night, the servers get overwhelmed and the entire app crashes. The original developers are exhausted. The code has become so difficult to navigate that adding a single VIP table feature takes them 3 months instead of 3 hours. Most of a software's life happens here. The tiny dot on the left is the initial build, while the massive block that stretches out for years represents ongoing maintenance. Maintainability is the set of design choices that makes living in that massive block survivable for the team. To stop TableSnag from collapsing, the engineering team has to rebuild their system around 3 core pillars: operability, simplicity, and evolvability. The first pillar is operability. This describes the practice of making routine tasks easy and keeping the health of the system visible to the people running it. Think back to that Valentine's Day crash. The engineers were panicking because they had no idea why the system broke. It failed like a closed black box. This dashboard shows operability in action. Instead of guessing, the team looks at real-time data pinpointing the exact bottleneck. Good operability also allows for safe recovery. If an update causes a problem, an engineer can press a single button to roll the system back. This changes a business-ending outage into a minor, fixable blip. The second pillar is simplicity. In system design, simplicity describes how easy it is for an engineer to look under the hood and understand what the code is doing. Over time, systems often develop accidental complexity. These are tangles in the code that aren't actually part of the problem the software is trying to solve. They're just the result of messy coding over time. Accidental complexity creates a mess of tangled wires. The logic for booking a table gets tightly knotted with the code for promotional emails. Good design separates these functions. Isolating the booking logic from the email code ensures a change to one won't break the other. This allows a junior engineer to fix bugs independently on their very first day, protecting the team's time and mental health. The third pillar is evolvability. This is the system's capacity to bend and adapt to new demands without snapping. Imagine the marketing team suddenly needs a prepay for VIP tables option live by next week. In a brittle system, this is dangerous. Touching the payment code might unexpectedly break the restaurant search function because everything is too tightly connected. In an evolvable system, we can swap out old features for new ones, while all the surrounding parts remain active and unaffected. When the market changes, the team can pivot gracefully rather than being held back by their own code. By focusing on these 3 pillars, the team stabilized TableSnag. They turned a fragile system into a foundation that the business can actually rely on. Operability keeps the lights on, simplicity keeps the team sane, and evolvability keeps the business moving and staying competitive. The true cost of software lies in the years of ongoing work, not the initial launch. In a healthy architecture, engineers work with a sense of calm confidence. They know that when they deploy an update, the system will behave exactly as they expect. Prioritizing maintainability allows a team to keep building new things year after year. It ensures the software remains useful and easy to change for as long as the business needs it.